Hi, so in this lesson today, we're going to be learning how to subtract digits, numbers in different bases. So start with base 2, and I think which is one of the simplest. So we have 1 minus 1, that's 0. 1 minus 0 is 1, less than 2. 0 minus 1, that's not possible because 0 is less than 1. So we're going to borrow 1, just like we do the normal counting. We're going to borrow 1 from here, and this one becomes 0, and you have 1 here. So you've borrowed 1. Now when time you borrow 1 like that, that one you've borrowed, change that to your base. So 1 now becomes 2. So 2 plus 0, you basically have 2. And 2 minus 1, you have 1. Fine. And then you have 0 here, and then you have 1 here. And so you have that in base 2. And so that's how to find your answer. So look at this example. Can you try this? So you can pause the video and try this on your own. Alright, 1 minus 1 is 0. Okay, 0 minus 1, that's not possible. So I have to borrow 1 from the next. So that becomes 0. Right that here. So that becomes 0. And we borrow 1 to this. Now, think of that 1 as the base. The base is 2. So that's 2 plus 0 is 2. 2 minus 1 is 1. 0 minus 1 in this, 0 minus 1, practically impossible. And this is 0, this is 0. So definitely I have to go as far as here to borrow 1 from here. So 1, this one becomes 0. And I add that to this. So 1 that I see here is actually 2. So 2, I'm going to take away 1 from 2. It becomes 1 back. Okay. Then I'm going to give it to this. But I still have to take away 1 from this. And remember, that one that we added now becomes 2. 2 plus 0 is 2. So that 1, 0 means 2. So take away 1 from 2. What we get is 1 again. Okay. Then I add it up to this. Okay, let me change the color so that you can see that properly. One, 0. Okay, so that basically means 2. And so 2 minus 1, you have 1. And so I have 1, and I have 1 left here. Then 0, I don't need to write that. So that's in base 2. So basically, when you borrow from a particular digit, that digit that you're borrowing from reduces by 1. Then when you add it to the following digits, it increases by the value of the base. If the base is base 2, then what you've just transferred to the next value is actually 2. And if your base is base 3, you just add it to base 3. Alright, so we have this digit, and this digit are actually in base 7. They are both in base 7. Okay, so let's have that. 2 minus 2, basically 0. 3 minus 2, 1. It's less than 7, so we can write that. 5 minus 3, 2. Less than 7, so we could write that too. So I think we're pretty lucky this time around. I hope we're not lucky the next example. So this is 2, 1, 0 base 7. So looking at this example, we have 7, 2, 5 base 8 minus 5, 3, 6 base 8. So how do we subtract these values? So this is not going to be easy as the first one we did earlier. So these are the point that you have to listen very carefully, because this is where things get very complicated. All right, so we have 5 minus 6 is practically impossible. So what we're going to do is going to borrow 1 from 2. So if I borrow 1 from 2, this one is left with 1. And so I'm borrowing 1 from this to this. So I've said earlier that anytime you're borrowing, the digit you're borrowing, the value you're borrowing, 1 in this case, is actually the base, the value of the base. What's the value of this base? In this case, is 8. Definitely, I borrowed 8 from 2. So that's what we think of it as. So 8 plus 5 is actually 13. So I'm going to think as all of these as 13. So 13 minus 6, what I have is 7. So basically I have 7 here. Okay, good. Now I have 1 here. 1 minus 3. 1 minus 3 is not possible. So I'm going to borrow 1 from here. So this becomes 6. And I borrow 1 here. 1. Now the one that I borrowed becomes 8. The value is 8. 8 plus 1 is 9. 9 minus 3 is 6. Good. 6 minus 5 is actually 1. 1 is less than 8. So that's it. So all of the digits must be lesser than the base. So, and that's in base 8. So that's the answer to this problem. Alright, looking at this question, I know it looks scary, but I would advise that you just pause the video and try it out yourself. Alright, so we know that the value of A is actually 10. So 1 minus 10, that's practically impossible. So I'm going to borrow 1 from B. If I borrow 1 from B, B is going to be less than 1, and that becomes A. Okay, so I have 1 here. Now, I said that anytime you borrow 1, the value of that 1 you're borrowing is actually the value of the base. In this case, we're dealing with in base 13. So that's the 13. 13 plus 1 becomes 14. 14 minus A is 10. That's 14 minus 10 is actually 4. Okay, so I have 4 here. A minus 2 makes sense. A is 10. 10 minus 2 is 8 in base 13, still less. So I can basically write 8. 8 minus 3 is 5. And that's in base 13. Okay, so that's the answer to that problem. Looking at this example, pause the video and try this yourself and see what you get. Alright, so 2 minus D. Obviously, 2 is less than D because D is actually 13. So 2 minus 13 is not possible. So what I do is I'm going to borrow 1 from 8. When I borrow 1 from 8, this becomes 1 less. That's 7. And this one becomes 1. So I told you that when you borrow 1 and you have 1 to a digit, the one you're borrowing has the value of the base. In this case, the base is actually 15. So that's 15. That one there is 15. This one is 15. 15 plus 2 is 17. 17 minus D, where D is 13. And that's 4. Okay, so we have 7 minus 3, which is reasonable, 4. And D, which is actually 13 minus 5, that's 8. So basically we have 8 4 4 base 15. So that's the answer to this question.